Hi students, welcome to PK's Learning Stations. Today we are going to discuss about in electrical circuit subject mesh analysis. So the question is calculate the current flowing through the various resistors shown in the given circuit diagram using a mesh analysis method. Yes. So first you should identify the number of meshes. So before going to identify the meshes, you should give the names for each node points. So I will name the node points A, B, C, D, E, F, G, and H. So I listed the names for the nodes. So first you should identify the number of meshes. So the message is a closed path, does not contain any inner loop. Okay, you can see here. So I start from this point A. So the mesh should be a closed path. So where you have started the node, right? The same point we should stop, right? So starting from A to B, B to G, G to H, H to A. This is the one mesh. So I will name the meshes. The one is A, B, G, H. This is the one mesh you can consider, right? This is the, I will name it as mesh 1. Similarly, I identify the another mesh. So B to C, C to F, F to G, G to B. Starting from B, B to C, C to F, F to G, G to B. So starting from B, again it reaches B. So that is a closed path, right? So this I can name it as mesh 2. Then I can go for the third mesh, C to D, D to E, E to F, F to C. C to D, D to E, E to F, F to C. So start with C, then end with C. So this I can name it as mesh 3. Then I want to assign the current for each mesh. So I will assign the mesh 1 current as capital I1. I want to identify the mesh 2 current as capital I2. I want to identify the mesh 3 current as capital I3. So we can assume the current direction either a clockwise or anti-clockwise. First, I recommended you all to assume the current direction in clockwise. Even though the current is flowing in anti-clockwise direction, initially we may not know it. So which direction the actual current is flowing. So always you can assume all the mesh currents are in clockwise directions. Okay, so we'll assume the mesh 1 A to B, B to G, G to H, H to A as a mesh 1. I can assume the mesh current as I1, capital I1. Then the mesh 2 I assumed as B to C, C to F, F to G, G to B. I will assume the mesh 2 current as capital I2. Next mesh 3 C to D, D to E, E to F, F to C as a mesh 3. So the mesh 3 current is I3. All the three currents I assumed in clockwise directions. Yes. Next. So for mesh analysis, you have to use only a KVL method. So what is the KVL? Kirchhoff's voltage law. We want to apply a KVL. The KVL is nothing but Kirchhoff voltage law. So what is Kirchhoff's voltage law? In a closed loop, in a closed loop, in a closed loop, sum of the voltages, sum of the voltages, or we can write it as sum of the potential rise is equal to sum of the potential drop. So yeah, in a closed circuit, so sum of the potential rise is equal to sum of the potential drop. So what is rise and what is drop? So mostly all the passive elements are considered under dropping elements. All the resistors will create only potential drop. All the resistors will create only a drop. Next, so what about the risers when you are going to see the sources, for example, this is a source which are having a 10-volt voltage source. So as per the current direction, so the current is flowing in this way. For example, some current I1 is flowing, right? If the current is flow from minus means lower potential, plus means higher potential. So if your current I1 is flow from lower potential to higher potential, which means potential rise. So which will bring potential rise. The same thing, we have another voltage source, right? The current which is flowing through this is something like I3. So now the current is flow from higher potential to lower potential, higher potential to lower potential. Then it is potential drop. Potential drop. Remember this. Whatever it is potential rise. So the depending upon the current direction, the current is flow from negative potential to positive potential. It is potential rise. The current is flow from higher potential to lower potential drop. Remember this. Okay. Now we can go for applying the KVL for each mesh. We have to write a three equations because we have three mesh. Apply a KVL for each mesh, and you want to write a three equations. Okay. So now I am going to apply KVL for mesh 1. Okay. What is my mesh 1? The mesh 1 is, so apply KVL at mesh 1. Yes. What is a mesh 1? So A, B, G, H, A, B, G, H. What is the current direction for this? So the flow will be this way, right? A, B, A to B, B to G, G to H, H to A. This is the direction which is flowing, right? Yes. So as per that, so you know the Ohm's law, right? What is the Ohm's law? So if we are having a resistor, then voltage is directly proportional to the current at constant temperature. As per the Ohm's law, the Ohm's law we are applied for the resistor, right? Resistor only. So there we can say V proportional to I. So when your V proportional to I at constant temperature. So normally you studied in your school that V is equal to IR, the same, right? So the first one, so all the resistors are making a drop. So I want to write it all the resistors into the drop side. Okay. So there is a equal. So the first drop will be a voltage across the 2 ohm resistor. So the what is the current which is flowing through the 2 ohm? This only I1 current will flows, right? Only the I1 current which flows. Okay. The I1 current which flows. Okay, the I1 current will flows. So the 2 ohm resistors are carrying only the current I1. So V is equal to I into R. So I is nothing but I1. R is nothing but 2. So I1 into 2, that is nothing but 2I1. 2I1. Then next there is a 4 ohm resistor that is also creating the drop plus 4 into what is the current? The current which is I1 is flowing here, and the 4 ohm resistor is not only carrying the current I1, it is also carrying the current I2. How the current I2 will flows? B to C, C to F, F to G, then G to B. This is the current I2 directions. So I1 current is coming down, I2 current is going up. So I1 will flow from B to G, I2 flow from G to B. Both the currents are opposite. But you are writing the equation with respect to the I1. So I1 current minus the opposite current because both the currents are flowing in opposite direction. I1 is this direction, I2 is this direction. So both the currents are opposite. So the difference in current will flow through the 4 ohm resistor. So what is the difference whether it is I1 minus I2 or I2 minus I1? So I am writing with respect to the mesh 1. So then I1 minus I2. Okay. Then what else? No resistor, no element. Then H2A. H2A there is a voltage. So what happened? The voltage lower potential to higher potential, which means potential rise. So the 10 volts should be written as the potential rise. The potential rise is on left hand side. Now we can simplify this. What is the equation? So 2I1 plus here 4I1 totally 6I1 minus 4I2 which is equal to 10. This is equation number 1. 6I1 minus 4I2 is equal to 10. Okay. This is for mesh 1 equation. Right? This is equation number 1. Next, I can go for applying a KVL at mesh 2. Applying KVL at mesh 2. What is mesh 2? Starting from B to Z, C to F, F to G, G to B. So first we can start from B to C. What is the current which is flowing through the B to C? Only the current I2 will flow because only the current I2 will flow, right? So now 2.5 I1 that is also creating the drop. 2.5 I2. Next, coming to the 5 ohm resistor. The 5 ohm resistor also carrying the both the currents. Similarly, the current I3 will flow from C to D, D to E, E to F, and then F to C. The current I3 is flow from F to C, but I2 current will flow from C to F. Again, the both the currents are opposite, so difference in current will flows. So I am doing with respect to the mesh 2. So mesh 2 current minus mesh 3 current, and then there is no element. Again, the resistor which is creating only the drop. Again, there is a resistor which is creating only the drop. So 4 into what is the current now? Again the same. I1 and I2 both the currents are opposite. But now I am writing the equation with respect to the mesh 2. So the mesh 2 current minus mesh 1 current. Remember this. So which mesh you are doing the equation? So the corresponding mesh current minus another mesh current. So there is no potential rise there. So then potential rise will be a 0. So what is the equation? You can simplify the equation further. So 2.5 I2. So here 5 I2 totally 7.5. So here also for totally 11.5 will be coming. So what about I1 first? First write the I1, right? So plus into minus minus. Minus 4 I1 minus 4 I1. Then what about I2? 2.5 I2 here, 5 I2 here, 7.5 I2. 7.5 plus 4. So totally 11.5 I2 plus 11.5 I2, 11.5 I2, right? Then coming to the I3, so minus 5 I3, minus 5 I3, which is equal to 0. This is the equation number 2. From mesh 2, we find out the equation 2. Okay, yes. Next, we can go for applying mesh 3. Now we are going to apply KVL at mesh 3. So apply KVL at mesh 3. What happened for mesh 3 KVL? So I will start from the mesh. C to D, D to E, E to F, F to C. First I start from C to D. The only current I3 is flowing. Only the current I3 is flowing, right? So the resistor will create only the drop. So what happen? We have to put it as drop side. So 1 into I3. It should be only I3, right? 1 into I3, it should be I3. Next. So there is a voltage. So voltage source will be current is flow from positive potential to lower. That is the higher potential to the lower potential. Then, which is nothing but potential drop. I want to put it on the drop side. The 4 volts would be I added with the drop side. So no element from F to E. Then F to C. What happened F to C? So F to C, 5 ohm resistor carrying both the current I3 and I2. Both are opposite direction. So each is also creating the drop plus 5 into corresponding mesh current. So I am doing with mesh 3. So mesh 3 current minus mesh 2 current. Why it is a minus? Because both are opposite current. Both the currents are flowing in opposite. Okay. Yes. So there is no potential rise, 0. What is the equation now? I1 first. There is no I1 here. So leave it. Next I2. So minus of 5I2. Minus 5I2. Then what is I3? Here 1I3. Here 5I3. Totally 6I3. Plus 6I3. Then this 4 I can move it to that side. Okay. So the 4 will become a minus 4. Now this is the equation 3. So now by solving equation 1, 2 and 3, we are getting I1, I2, I3 by solving this equation 1, 2, 3. So what are the equations? Right? What are the equations now? We are getting. So the equations are, I write down the equations here. 6I1 minus 4I2 plus 0I3. Right? There is no I3, right? 0I3, which is equal to 10. Equation number 1. Then what about the equation 2? Minus 4I1 plus 11.5I2 minus 5I3, which is equal to 0. Equation number 2. Then what about third equation? So there is no I3, right? Here there is no I1. Then we have to write it as 0I1 minus 5I2 plus 6I3, which is equal to minus 4. Equation number 3. By solving the equation 1, 2 and 3, we are getting the value of I1, I2, I3. Finding the current I1, current I2, current I3. So what are the currents? How to solve this? Current I1, I2, I3. We can use any method. You can solve by a grammar rule, or you can solve by equation mode in your calculator. We can solve with any method. So I am going to solve with the calculator with the equation mode. So number of unknown is 3 unknowns. You have to choose 3 unknowns. Then you have to type your values, right? So these values are, if you are solving by calculator equation mode, they will ask for 3 datas, right? They will ask A, B, C, D, right? They will ask A, B, C, D. So these are the A coefficient, these are the B coefficient, these are the C coefficient, these are the D. The I1 coefficients are A, I2 coefficients are B, I3 coefficients are C, and the right hand side values are D. So whatever the values there, A1, B1, C1, D1, this is A2, B2, C2, D2, A3, B3, C3, D3. This is the one, right? We want to type as it is, right? So by solving of this, I will write the answer. Just a minute. So 11.5 minus 5, so 0, 0, minus 5, 6, minus 4. So the answers are, the I1 is, by solving the equation mode, we are getting the answer is 2.14 amps. At least you should write a 2 decimal points. Okay. Amps. Then our I2 is 0.71. 0.71 amps. Next I3 is, so minus 0.07 amps. So if you are getting this minus for I3, so we have to write one line that our assumed direction is wrong, right? Our assumed direction is wrong. The actual current will flow from the opposite directions. But as for our right, as for our circuit diagram, we assumed your I3 is this direction. We are getting a negative answer. So actual current will flow from this way. Okay, actual current will be flowing in anti-clockwise direction for I3. Other two currents are whatever the direction we assumed is correct. Okay. Now what is the question? Calculate the current flowing through the various resistors. Now we are going to find out the current flowing through the various resistors. So what are the currents? How to find out those currents in various resistors? So the current which is flowing through the 2 ohm resistor, right? The current which is flowing through this 2 ohm resistor, right? Current flowing the 2 ohm resistor is, what is the current which is flowing? Current I1. Because only the I1 current will flows. What about the current flowing through this 4 ohm resistor? I1 and I2. I am taking the current from B to G. So the same direction is I1. I2 is opposites. So the current which is I1 minus I2. I1 minus I2. What about the current flowing through this 2.5? It is I2. What is the current flowing through this 5 ohm? Both the currents are same opposite. I will take from C to F. So I2 minus I3. I2 minus I3. What about the current flowing through the 1 ohm? Only the current I3 will flows. So I will write it out those things here. The bottom. So you have to find out that I2 ohm. Your I2 ohm is nothing but I1. What is your I1? 2.14 amps. What about the current flowing through this 4 ohm resistor? I1 minus I2. I1 minus I2. So what is the 4 ohm resistor? This one, right? The current flowing through the 4 ohm resistor is I1 and I2 both is going. I will find out the 4 ohm current is B to G. Okay. I1 minus I2. What is my I1? What is my I2? 2.14 minus 0.71. What is the answer for this? 2.14 minus 0.14 is, so 2.14 minus 0.71. The current is 1.43 amps. 1.43 amps. Then I want to find out the current flowing through 2.5 ohm resistor. What is the current flowing through the 2.5 ohm resistor? The 2.5 ohm resistor is current I2. Okay. Current is I2. Yes. The current is I2. What is the current I2? 0.14 0.71 amps, 0.71 amps. Then what is the next? We have to find out the next current, right? I5 ohm. Our I5 ohm is I2 minus I3, which is C to F. C to F. So I5 ohm, I5 ohm is I2 minus I3. What is the value? For I2 is 0.71 minus 0.07. So now 0.07 will be added there. So 0.78 amps. 0.78 amps. Next, we can go for finding the current flowing through the 1 ohm resistor is I3. 1 ohm resistor is I3. Current flowing through 1 ohm resistor is I3, which is equal to minus 0.07 amps. 0.07 amps. So now the current is not in the negative. So you want to write it out. The actual current of I1 ohm is flow from what is the value? D to C, right? Not from C to D. The actual current which is flow from D to C, the actual current, right? Current I1 ohm is flow from D to C, the actual current, right? Okay. So this is about your mesh analysis. I will recall the mesh analysis once. So we have a recall. So first we should identify the nodes, name the nodes A, B, C, D, all. Then we have to, what is the node? Generally, what is the node? So the two elements connecting point. So here there is a element 10 volt is coming here. The connecting point is node A, node point, right? You have to name the nodes A, B, C, D, E, F, G, H. So then you have to identify the meshes. The meshes are independent loop. There is a loop. Loop is also mesh or loop is a closed path generally, but the mesh is nothing but it does not contain any other inner loops. It does not cover any other inner loops. So that's why it is a independent loop. The name it is called mesh is nothing but a independent loop. So does not contain any other elements, right? So identify the three meshes. So mesh 1, mesh 2, mesh 3. Then name the mesh currents are I1, I2, I3. So I assumed all the currents are in clockwise direction. Then I want to apply the KVL for each mesh. So how we can apply the equations? So in a closed loop, sum of the potential rise is equal to sum of the potential drop. You want to write a KVL, apply KVL for each mesh. You can form the number of equations. So three mesh, we need a three equations. So three unknowns, we need a three equation to solve. Okay, each mesh will give a each equation. Then you can solve this equation by equation mode or something. Then you have to identify the current flowing through the each resistors. Okay, so this same problem we can also solve by matrix method. So there is a method called matrix method. So we will discuss in the matrix method also. Okay. So I will take down this problem. I will solve the same problem by matrix method. Okay, I will explain by matrix method. Okay, yes. So this is your problem, right? So the matrix method also same procedure. So identify the number of nodes, name the nodes, then find the number of meshes, then assume the mesh current, the same thing, right? So now we identified that. So so these are the nodes we already identified A, B, C, D, E, F, G, H. Then assume the mesh current for each mesh. The mesh 1 already we discussed. A, B, G, H, A, mesh 1. Then B, C, F, G, B is I2. Then mesh 3 is C, D, E, F, C is a I3. Yes. So the matrix method, the procedure is the same. The matrix method also we are going to apply the KVL. The KVL, what is that? V is equal to IR, right? So as per the voltage equations, V is equal to IR. So we have to form it in matrix directly. So first we have to form a R matrix into the unknown currents, which is equal to the voltage source in the mesh. This is the equation. V is equal to IR only you are going to form. First you have to form a R matrix. So the condition for applying this matrix method is, so we need all the sources are should be a voltage sources in your circuit. The sources, right? The independent sources which is available in your circuit should be a voltage source. All sources are only voltage, so then only you can apply the matrix method directly. Okay, so note down this, right? So first you have to form R matrix, then I matrix, then V matrix. Your I matrix and V matrix are a column matrix. Your I matrix and V matrix are a column matrix. Your R matrix is a square matrix. So what is the size of your matrix? So depending upon the number of meshes. So how many meshes here? So it should be a 3 meshes. Then the R matrix should be a 3 cross 3. Or R matrix should be a 3 cross 3. Or R matrix size. It's a square matrix. Then size should be a based on the number of meshes. So 3 meshes. So the size should be 3 cross 3. So the current will be a matrix should be a column matrix. So it should be a 3 cross 1. It should be 3 cross 1. The voltage matrix also should be a column matrix. 3 cross 1. Yes. Okay. Now we are going to form a matrix. So the matrix first we have to form a row matrix. Okay, that is R matrix. Sorry, R matrix, right? Yes. Okay. Yes. So first we can form R matrix. So the matrix R should be a, we have a two parameters in the matrix R. So we'll not do the other colors, right? Yes. It should be a 3 cross 3 matrix. So I want to form a 3 cross 3 matrix. First row, second row, third row. Right? Similarly for first column, second column, then third column. Okay. Then there should be a current matrix. What are the currents? So already we assumed the unknown currents, right? The mesh currents are I1, I2, and then I3, which is equal to voltage equations. So you have to identify the number of sources in the mesh. Then you have to put if it is a potential rise plus, drop means minus. We'll see one by one, right? Yes, yes. Okay. So we have a two kind of elements, right? So normally row 1, row 2, row 3, column 1, column 2, column 3. Okay. So the row 1 and column 1 will represent the mesh 1. The number 2 will represent the mesh 2. Number 3 will represent mesh 3. Okay. So first we have to go for, there is a two kind of elements. One will be a diagonal element. Diagonal element 1 1, right? Diagonal element 1 1, 2 2, and then 3 3. There is a diagonal element 1 1 2 2 3 3. Okay. So when you are writing a diagonal element, you have to add all the resistors in the mesh. You have to add all the resistors in the mesh. So what are the resistors in your mesh? You can see what is the first mesh? A to B, B to G, G to H, H to A. What are the resistors here? So there is a 2 ohm resistor and 4 ohm resistor. Two resistors are there. Others are no, right? Only voltages. So only two resistors in the mesh. 2 and 4 add directly. 2 plus 4. So the diagonals are sum of the resistance in the corresponding mesh. So diagonal 1 for mesh 1, add the resistors in that particular mesh path. That's it. So now what about the mesh 2? So the mesh 2 is B to C, C to F, F to G, G to B. So B to C it is a 2.5, then C to F it is 5, then F to G no, G to B it is a 4. G to B it is a 4. These are the diagonal elements. We have a 3 resistors in the part 2.5, 5 and then 4. Add all the resistors. Next coming to the third diagonal, the third mesh, right? C to D, D to E, E to F, F to C. So C to D 1, so is the source, leave it, no element. So F to C is a 5. F to C it is a 5. 1 plus 5. Okay. The diagonal elements are sum of the resistance in the corresponding mesh. First diagonal for first mesh, second diagonal for second mesh, third diagonal for third mesh. Yes. Next, going for half diagonal, right? The other element is half diagonal. So what is half diagonal? You have to identify the resistor between the meshes. You can see here there is a 4 ohm resistor, right, which is connected between mesh 1 and mesh 2. Mesh 1 and mesh 2. So when you are looking into that, the current directions, you want to check the current directions. If the 4 ohm resistor was carrying a two currents, right? One is I1 and I2. If both I1 and I2 current direction are same direction, then the half diagonal should be a plus of that resistance. Plus of that resistance. If currents are opposite, for example, the 4 ohm will be flow from this I1 current is flow, the 4 ohm is B to G. But I2 current from G to B, both are opposite. If that is the case, negative of the resistance. If both the currents are same direction plus that resistance, if both are opposite, then minus that resistance. So here I1, I2 are opposite direction, so minus the resistor is common resistor is 4, minus 4. So 1, 2 and 2, 1 should be same. This 1, 2 and this 2, 1 should be a same because the mesh 2, 2, 1 also same 4 ohm, same currents are opposite. Okay. Similarly 1 and 3. So what is the common resistance between 1 and 3? The resistor should carry the current I1 as well as I3. So there is no such a resistor here. There is no such a resistor here because the I1 will be in this mesh, I3 will be in this mesh. There is no common resistance between. So if that is the case, put a 0. If there is no common resistance between the mesh, then you have to put the corresponding off diagonal element as 0. Then element 2, 3, right? This is the element 2, 3. What is the 2, 3? Mesh 2 and mesh 3. The common resistor is 5 ohm. The mesh 2 and mesh 3, the common resistor is 5 ohm. Current directions are opposite. Your I2 is flow from C to F, I3 flow from F to C. So, minus of the resistance 5 ohm, minus 5. So, what about the right hand side voltages? So, you have to go with the voltage. So, check with the each and every. Okay, we can see now. So, as for the mesh 1, so 2 ohm, 4 ohm, then 2 ohm, 4 ohm, then only one voltage source. The current is this direction, minus 2 plus, already told. Lower potential, higher potential, which is the rise. If it is a potential rise, put a plus. So I am looking into the first mesh. So I want to write it as the first row plus 10 volt. There is no other voltage sources in the mesh 1. That's all. Next, mesh 2, B to C, C to F, F to G, G to B. There is no voltage source. If that is the case, there is no voltage source, then put a 0. Then coming to the mesh 3, C to D, D to E. What is the D to E? The current direction is this way. So higher potential to lower potential. So which means drop minus of 4 volt. Why minus? Because higher potential to lower potential which create the drop. So minus 4. Okay. So there is no other sources here. Okay. So this is the matrix equations. So we can check with our earlier equations, right? So what is the final? So 6 and this one is 9 plus 1 it is 11.5. This one is 6. Okay. You have to check your previous one, right? Equations 6I1 minus 4I2 0 I3. 6 minus 4 0, right? The coefficients alone will come. 6 minus 4 0 and 10. 6 minus 4 0 and 10. Next, what about the second one? Minus 4 11.5 minus 5. Minus 4 11.5 minus 5, then 0, right? Similarly, what about I3? Third equation 0 minus 5 6 minus 4. 0 minus 5 6 minus 4. The same equation you will get. Okay, then the remaining is same. You can solve by a calculator or grammar rule. You find out I1, I2, I3. Then you can find out the current flowing through the various resistors. So thank you for all. So any doubts, please put it in the comment window. Okay, thank you for all.